In this concept video, we're going to be discussing end behavior and also where a function is increasing, decreasing, or constant. Let's start off with end behavior. The end behavior is kind of how it sounds. It's how the ends of the graph behave. But we're really only worried about the y value here. So I'm going to put in parentheses. We're wondering, what does that y value do? There's lots of different ways to state end behavior. Let me give you one that's often used for students that have not had access to these things called limits yet, which is a basic building block of calculus. What we can do is simply state, as x approaches negative infinity, y approaches some number. You don't have to write the rectangle, but the rectangle is like, hey, there's a missing value here, okay? So as x approaches negative infinity, that's all the way on the left end of the graph, and so this is the left end behavior right here. The right end behavior then would be x approaches infinity. By the way, this little arrow here, that means approaching or approaches. So as x approaches infinity, that's on the right hand side, we're wondering, what does y do? So we want to list where those y values are going or approaching. Notice how there really isn't a y value at infinity. Infinity is just a concept. However, we can state sometimes a value that the y is approaching. Let's look at the concept note graph here. And I forgot to draw some arrowheads on this thing, so let's do that. That's actually pretty important. Make sure you put these arrowheads on here. Okay, so if we're stating the end behavior, so we'll do end behavior here. We always do x, the little arrow means approaching. You can do negative infinity, or you can do infinity first, but you have to catch each one. And then we're wondering what value, or what values does y approach. So let's take a look at the left end behavior. We don't really care what's happening in the middle of the graph, it's end behavior. So you can imagine as x goes to negative infinity, this graph would keep going to the left but also be decreasing. So we know the graph is going to the left and the values of y are decreasing to negative infinity. On the right hand side, we've got y approaching some value. And actually this time it's not approaching a value at all, it's continuing to increase. We can make x as big as we want, and this graph will just keep going up and up and up. So the y value would approach infinity for this one. So there's your end behavior. Pretty easy for the most part. It doesn't have to be infinity or negative infinity. Sometimes a graph approaches a horizontal asymptote, and so you can list an actual value there. Increasing, decreasing, or constant. So this is always from left to right. So let me put that here. Always, oops, let's do not left slash right, left to right. So just like you read, or if you were looking at a number line, you go left to right, and that's how we want to look at this increasing, decreasing, or constant thing. So, and this time we're going to state these as intervals. So these are stated as intervals where the graph is doing that right there. You can use set builder notation, or you can use interval notation, and we're going to use interval notation in this class. Let's look then at the concept graph, and I'll write down here increasing, decreasing, or constant. And we always remember go from left to right. And so the graph is considered to be increasing if from left to right the values of y are increasing. Notice how the values of y are increasing or going up until this point right here. So if you were to go to negative infinity and then continue all the way to negative 2, you would be going up the graph, or you'd be climbing or increasing. So we want to write our increasing interval starting off as negative infinity to negative 2. Some people will argue that you should include this negative 2. However, I like to use parentheses because for me, at this point the graph is neither increasing or decreasing. At this very point, it is constant, but you will find some definite argument out there about that, and I won't get very sticky about it. If you put a bracket or a parenthesis, that's fine as long as you have that value here. Now what we're going to do is take a look at this other portion of the graph, and I'll go with a different color here for you. So we're going to do the decreasing portion right here. And so at this point, we're still moving left to right. We're kind of going like downhill or down a coaster from -2 to this point. If you were to go from left to right only, and again, that is the concept here, we are only going from left to right, the graph would be decreasing. So we want to list our decreasing interval as from -2 to 0. Notice we are only worried about the x values here. I am not concerned at all with the y values, because when we say decreasing, we mean the y values are decreasing. We're wondering what values of x does that happen. The next one here is going to be increasing again, so I'll switch colors back to the orange, and we're going to be going up this side, and we're going to go up until infinity. So if the graph is also increasing from 0, so we'll do a union, so we'll go 0 and then all the way to infinity. And that's really about it. There's really nothing more to this stuff. End behavior is as we look all the way to the left or all the way to the right, what are the y values doing? And when we talk about whether a function's increasing, decreasing, or constant, we always go from left to right, and we're concerned about the x values where the function is either increasing, decreasing, or in some cases remaining constant.